Alright, so now we're going to do problem 9. Problem 9 states, find the absolute maximum and minimum values of f of x equals x times x minus 6, that squared, on the interval 1 to 4. Okay, in order to find the absolute max and min, we have to find critical points, and we also have to look at our endpoints of our domain. So 1 and 4 are also critical points. So even though we find critical points by making the derivative equal to 0, we also must include 1 and 4 as our critical points. Just putting that out there. Alright, so now, let's go ahead and find our first derivative and make it equal to 0. Alright, so our first derivative. We have a function times a function, got to use the product rule. Alright, so the product rule, let's go ahead and take the root of x first, that's 1 times x minus 6 squared, plus, now the derivative of x minus 6 squared, that's 2 x minus 6, times the derivative of the inside, that's just 1, so I'm not going to write that, times x. Okay, let's do a little simplification here. We have 6 minus x squared plus 2x 6 minus x. We can go ahead and factor out a 6 minus x. X minus 6, not 6 minus x. X minus 6. And then that's x minus 6 plus 2x. And then f prime of x is equal to x minus 6. X plus 2x, that's 3x. So we have 3x minus 6. Okay. Then we go ahead and factor out a 3. Factor out a 3, we're left with x minus 2. So now we have the first derivative. Alright, we want to find the critical points. So, finding critical points. So, since we don't have a rational expression here, the domain is all real numbers. Therefore, all the critical points that we're about to find are defined at f of x. Right? Because we have f of x here, so they're all defined here. So, they're not are possible, they are the critical points. So, let's go ahead and equate this whole thing to 0. So if we equate that to 0, 3 is gone. We're left with x minus 6 equals 0, and x minus 2 equals 0. Therefore, we're left with x equals 6, and x equals 2. Alright, so these are our two critical points, plus we have 1 and 4 as our critical points as well, because those are our endpoints, and they're included. Okay, so let's go ahead and draw our real number line. And we have 1, 2, oh, and 6. 6 is not in the domain of 1 and 4. So we can discard 6. Yes, definitely want to look back at the domain. We're only dealing with the domain of 1 through 4, so 6 is not in that domain, so we can discard it. So now we just have 1, 2, and 4. So let's put 1 here. Let's put 2 there. Let's put 4 there. Now I'm going to grab test points. So I can't grab a test point here and here, only in between 1 and 2 and 2 and 4, since that's our domain. So I'm going to go ahead and pick 3 halves, between 1 and 3 halves. And between 2 and 3, I'm going to pick 3. Alright, so now I'm going to test these points. So test the test points. Alright, so f prime 3 halves, what do we get? So come here, this f prime. So we obtain 3 times 3 half minus 6 times 3 halves minus 2. Alright, so I'm going to go ahead and find out what we get here. So here we're going to get 3 minus 12, that's minus 9 over 2. And then here we're going to get 3 minus 4, that's minus 1 over 2. So we get that. Alright, so we have negative times negative is a positive, has another positive, this is a positive number. So it's some positive number. That's all we care about. It's a positive number, therefore it does this. Okay, now let's find f prime of 3. So f prime of 3. F prime of 3 is going to be 3 times 3 minus 6. So 3 times 3 minus 6, but 3 minus 6 is minus 3. And then 3 minus 2 is 1. So we have 3 minus 3, that's negative 9. So it's a negative number. It's a negative number that's decreasing from 2 to 4. So what does that mean? At 2, there is a maximum. And then at 1 and 4, there are minimums. Okay, so we know the absolute one is the lowest one. So we have to find out which one's lower, either at x equals 1 or at x equals 4. We already know the highest absolute max is at x equals 2. So we want to find that. So how do we know what is the maximum? Well, let's evaluate f of 2. So our maximum, our absolute, so absolute max happens at x equals 2. And what is it at x equals 2? So plug in. So that's f of 2. F of 2, so f of 2 is 2 times 2 minus 6, that's minus 4, but minus 4 squared is 16. And 16 times 2 is 32. So our absolute max is at 32. Now we want to find the absolute min. Okay, so we know the absolute min is either at x equals 1 or x equals 4. In order to find the absolute one, we want to find out which y is less. So we have to evaluate f at 1 and f at 4. So let's go ahead and, okay, so f of 1, alright, f of 1 is what? We have 1 minus 6, that's minus 5, minus 5 squared is 25. Okay, now what's f of 4? F of 4 is 4, as well as we have 4 minus 6, that's minus 2, squared, that's 4, and then 4 times 4 is 16. Okay, so which one is the lowest one? 16 is the lowest one. So therefore, the absolute min, so let's erase this, so f1 is 25, therefore it's not. So therefore, absolute min is that x equals 4, and f of 4 is 16. There we go. So that's how you do that. So very important, when they give you an interval and they're asking for the absolute maximum, and they're giving you an interval where the endpoints are included, the endpoints are already critical points, plus the critical points that you find when you make the derivative equal to 0. Once you do that, put all your critical points on the number line, and make sure that if you have a critical point that's not in your domain, you have to cancel that out. That doesn't belong there. Once you have that, have your real number line, put all your critical points, get some test points, test to see if it's increasing, decreasing. Then that will give you a rough estimate if it's a max or a min. In this case, we have a max here at 2. We have 2 possible mins, but which we want to find which one is absolute. In order to find which is absolute, compare what f of 1 is equal to and what f of 4 is equal to, and look at the lowest one. In this case, 16 was the lowest one. So we have that. And that's it.